quadratic functions in factor form. Today we're going to do something a little bit differently, and we're going to review what we've done with factoring so far. So we need to remember the guidelines we created to factor. And the first thing we discovered was we always need to common factor first. Once we're done that, we have to look at the number of terms we have. And if we have 2 terms, we're going to look for a difference of squares. If there are 3 terms, we're going to look for a perfect square trinomial or a simple trinomial. If there are 4 terms, we're going to factor by grouping possibly, or look for a perfect square trinomial with a difference of squares. And at the end of it, when we think we've done all our factoring, we're going to look at each of our factors and decide, is each factor completely factored? So the first question we're going to factor is x squared minus 3xt minus 10t squared. So again, the first question we ask ourselves is there a common factor either within the numbers or the variable? And the answer to that is no. Now we're going to count our terms. We have 3 terms. So we are going to look for a perfect square trinomial or a simple trinomial. Could it be a perfect square trinomial? I've got an x squared. I've got a 10t squared. But 10t squared isn't a positive perfect square, which has to occur for it to be a perfect square trinomial. I need 2 positive perfect squares. And 3xt most definitely is not a positive perfect square. So my only option left is to look for a simple trinomial, or the only option I have today. So I look, and the coefficient of my quadratic term is a 1. And I've got a little bit of a monkey wrench here with that t squared going on. But I'm going to go with the flow for now and think about it, because if I take the square root of t squared, it's a t, and there's a t in my linear term. So to use a simple trinomial process, I need 2 numbers that have a product of -10 and a sum of -3. So I need to have 2 numbers that are opposites in order to get a product that's negative. And the sum has to be negative, so my larger digit has to be the negative digit. So 1 times 10 will give me -10, but it has a sum of -9. If I add 1 to 1, I get the number 2. So I'm always increasing by 1 to determine my product numbers, because it just makes sure I get all my factors that way. 2 times -5 gives me -3, and I'm done. If I weren't, I'd try 3, and it's not a factor, and 4, it's not a factor, and then by the time I get to 5, I'm going to start running through the same numbers again, so I would be done. Now you'll notice I took the 2 numbers that gave me the product, and these are the numbers that I dropped in here. And here, I did that the other way around. Let's fix that. And the thing to remember here is I did something a little bit extra. I added the t to each of those values, or I multiplied each of those constants by t. And the reason for that was I needed to get this t squared out in the end, and I needed my middle terms to have that xt, which you can see is going to happen when I expand. Next question, 3xy minus 3y plus 12x minus 12. What's the first question I ask myself? Is there a common factor? And the answer is most definitely yes, because I can see I've got 3, 3, 12, 12. They are all divisible by 3, so I am going to start by factoring that out. And when I divide 3xy by 3, I get xy. When I divide -3y by 3, I'm left with a y. 12x divided by 3 leaves me x, and -12 divided by 3 leaves me -4. And if I count the terms up inside my second polynomial, I have 1, 2, 3, 4 terms. So I have 2 options. It could be factoring by grouping, or it could be a difference of, or perfect square trinomial with a difference of squares. So let's look and see, can I factor it by grouping? Is there something common to any pair of factors? Well, if I look, these 2 have a y in common. These 2 have a 4. Also, I can look and say these 2 have an x in common, but those 2 don't have anything. So I'm going to go with the first 2 I saw, and I'm going to factor the y out of the first 2 and the 4 out of the second 2. So when I do that, I have to put an extra square bracket here just to keep things from getting confusing for me. I put the y in front. Xy divided by y is an x. y divided by y is 1. And I'm done factoring because I've grouped the first two terms. Now I need to group the second two terms. So I'm going to pull a 4 out, and 4x divided by 4 is x, and negative 4 divided by 4 leaves me negative 1. Now I can see that they both have a common factor of x minus 1, which I'm going to factor out, and here I'm left with the y, and here I'm left with the positive 4, and that's where this factor of y plus 4 comes from. And the 3 just stayed out in front. Part C, x to the fourth minus x squared y squared. First question I ask myself, is there a common factor? And the answer is absolutely. Not in terms of any numbers or constants or coefficients, but in terms of the variables. Each term has an x in it, with the least exponent being 2. So we're going to factor out an x squared. And when I do x to the fourth divided by x squared, I'm left with x squared. X squared y squared divided by x squared leaves me y squared. Now again, I need to ask myself, how many terms? In the first factor, it's x squared. It's a monomial. I can't factor that further. But x squared minus y squared is a binomial. So I need to ask myself, could this be a difference of squares? Do I have two perfect squares? So can I take the square root of x squared? Can I take the square root of y squared? Absolutely. Is one of them positive and one of them negative? Yes. And therefore that tells me I can factor it using the difference of squares method, which tells me take the square root of x squared and the square root of y squared and put them in as the first and last terms in each binomial. And one's going to have a positive in front of the second term, and the other's going to have a negative in front of the second term. And of course, I underlined them in the opposite orders, which I'm sure you guys figured out. Part D, 25x to the fourth minus 30x squared y cubed plus 9y to the sixth. Whoa, she didn't do anything like that in class yesterday. That's what you're all thinking, I know, but it's okay. You guys can handle this question. You just need to ask yourselves the right questions. Is there a common factor? 25, 30, and 9. New. X to the fourth, x squared, y cubed plus y to the sixth. No, there's nothing common. So now I need to look at my approaches. I count my terms. 1, 2, 3 terms. Is it a simple trinomial? Could it be a perfect square trinomial? Well, since none of the coefficients are 1, I can rule out simple trinomial right off the bat. If I look, I have 25x to the fourth. Well, that's a positive perfect square. 9y to the sixth, that's also a positive perfect square. So I am going to try and factor it as a perfect square trinomial. So when I do that, I need to square root 25x to the fourth, which is 5x squared, and I need to square root 9y to the sixth, which is just 3y cubed. And remember, we always take the sign from here, because at the end of the day, when we multiply, we need to have a negative times a positive and a positive times a negative to get our middle term to ensure that we've got negatives. And we should clean this up a little bit further because we're seeing the same factor written twice, so we should just state it once with an exponent of 2. Now we're not done because we don't have proof yet that this really was a perfect square trinomial. So I have to test my theory. And remember, this negative 30x squared y cubed should come from us multiplying the 5x squared, the negative 3y cubed, and multiplying by 2. So when I do that, is 2 times 5x squared times negative 3y cubed equal to the negative 30x squared y cubed? Absolutely. And I have to look at my factors in the bracket because there's a lot of stuff going on in there. I've got a 5x squared and a minus 3y cubed. There's no common factors. There are 2 terms, so I'm going to check for a difference of squares in here, and neither one's a positive, or neither one is a perfect square. So I'm actually done my question. Last one, ladies and gentlemen. First question is there a common factor? And the answer to that is no. How many terms are there? 4. So I look to see if I can factor by grouping. Well, I've got a common factor between these two. I've got a common factor between those two. But if I pair x squared and 6x together, there's no common factor with negative 4y squared and 9. And I don't see anything that's going to factor out in the first two terms to leave me that. And if I look at 6x and 9, there's not going to be anything that's going to give me that common factor, that common binomial later on. So I have to skip that approach. Now, what do I have to look for now? All right, that perfect square trinomial with the difference of squares. That's what I'm looking for. Do I see two positive perfect squares? Most definitely I do. I can take the square root of 9, and I can take the square root of x squared. So I'm going to try and work with that. So the square root of x squared, is x, and the square root of 9 is 3. So I'm going to drop that in there. Now the problem is I haven't used the 6x, and I haven't used the minus 4y squared. So where do I go? Oh, wait, I haven't proved it's a positive perfect square because I do have to end up with a middle term, right? So I need to consider what twice the product of the terms in the factor is. So in this case, it's what 2 times x times positive 3. Well, that is 6x. Oh, that's this term here, this 6x. So I've used it. I've used my x squared, I've used my plus 6x, I've used my plus 9, and the only thing I have left is my negative 4y squared. Now if I look at it, I should have bells going off because I see a perfect square, another perfect square, I see a positive, I see a negative, and I can just take the square root of the first term, which is x plus 3, and the square root of the second term, which is 2y, and I can drop them both in and make one a positive 2y and one term a negative 2y. And if I look at the factors in both brackets, there is nothing common. There are 3 terms, but there isn't a simple trinomial or a perfect square trinomial in either one. And that's it for today. I'm not going to bother giving you homework because I think you already have enough to do. And you can go back and practice some of the questions or go back and look at some of the questions that you've struggled with on other days and get those finished up.